Let's rewind and build a tree. The first event, choosing the coin, can lead to 3 equally likely outcomes: fair coin, and unfair coin. The next event, the coin is flipped. Each fair coin leads to 2 equally likely leaves, heads and tails. The bias coin leads to 3 equally likely leaves, 2 representing heads and 1 representing tails. Now the trick is to always make sure our tree is balanced, meaning an equal amount of leaves growing out of each branch. To do this, we simply scale up the number of branches to the least common multiple. For 2 and 3, this is 6. And finally, we label our leaves. The fair coin now splits into 6 equally likely leaves, 3 heads and 3 tails. For the bias coin, we now have 2 tail leaves and 4 head leaves. And that is it. When Bob shouts the result, "Heads!" this new evidence allows us to trim all branches, leading to tails, since tails did not occur. So the probability that he chose the bias coin, given heads occur, well, 4 leaves can come from the bias coin, divided by all possible leaves. 4 divided by 10, or 40%. When in doubt, it's always possible to answer conditional probability questions by Bayes' theorem. It tells us the probability of event A given some new evidence B. Though if you forgot it, no worries. You need only know how to grow stories with trimmed trees.
So, hello to everyone, and Svetlana, I see you join this event. So, let's continue today with week 14. For now, it was 5-minute presentation from Amazing Khan Academy until waiting. So, and today we continue with conditional probability and by theorem. And our topic by theorem and its applications. And one more time, biggest thanks to everyone joining today.
Thank you, Anna. Yeah, that was very interesting, the video you showed. I also saw a lot because they are really visually showing how it works. Very, very interesting. And the link you provided also in on the website, so, correct? This is the link to Khan Academy.
Yes. Mhm. Yes. Today or yesterday, I'm not sure. I found I checked Khan Academy course and found this link. I watched video and decided, oh my god, I should add this link into event page. Even for future, for someone who will check one more time list of lessons from AI Math Club. So I hope someone finds it useful because it's really very short but very descriptive with good example explanation. So, and
Then
I can stop sharing.
we can adjust this example with Python code and again check these conditional probabilities together. Let's check some.
And meanwhile, I remind that this session will be recorded. And of course, we are super friendly, supportive community, and we promote a warm and respectful environment for everyone. So let's encourage each other and, of course, lift one another up. And this session will be recorded and later today shared on our YouTube channel, so you can watch in other time because always it's not so easy for new in this topic understand from first time. For example, I like watch all recorded sessions one more time.
Okay, again, we in case my internet is still crazy, we're working with Vodafone, making some changes, but we saw this equation, so we are looking at these conditional probabilities, and we see something happened, and then the follow action, then the probability of something else has to happen. And so something happened, we are saying A and B, so probabilities, and then this connection between that we were had something already or not, so something new event is coming, and this connection describing these conditional probabilities, and after that this bias theorem. But starting again here, we can just also how we write these probabilities, and then in bracket we are saying A, the probability that we would see that A in case that B already is there. So this how we just write mathematically these connections, and the formula for conditional probability is probability A will happen in case that we have B, and then we see also there's this additional the probability that A so both the event A and event B occurring. So this in this writing, so you can see the description, and then we divide this probability over the probability that event B occurring, and through this formula we'll get then our probability that we are looking at, the probability of event A occurring given that B occurred. So this the condition. And let's have again some Python code with this. Let's consider an example. Rolling a fair, so 6-sided die, and event A would be the number rolled is 4, and event B, the number rolled is even. So after that, so see the B is occurred. So first we roll the die and we have an even, and then that this would be the number 4. And using this again equation, then we have the Python. So we define this sample space. So sample space would be all these numbers. So like here, 1, 2, 3, 4, 5, 6. Define the event. So event A would be that we are having number 4. Event B, the even numbers, 2. And then we are calculating probability, then this event B over this sample space. And then we, after that, after this calculation, using this equation, we have we can print this. So we can again copy the code and go to Colab. Straight, I make this Colab. Opening. And depending how you work with Gemini, I was asking Gemini, there are sometimes the possibility straight to open in Colab, but I think I have to again ask this. But we make it now separately, generating the code and then opening this one new new file. Okay. I have to close. New notebook. I pressed the wrong button. Just sorry. Just we can this the welcome screen, and I have to open. Hey, still welcome. A little bit. Where is my new file? Okay, here would also work. I can just close this one and making this bigger. So this cell is here. I'm running in this cell to get the probability, this conditional probability that we will get 4 in case that we are rolling the even. And the probability, here's we print this probability, and we are using again this equation. So here, calculating the probability of event B, then calculating the probability of intersection A and B. So here these both lines of code, and then putting all this together, calculating the conditional probability. So like you can also very quicker calculate this on a piece of paper. But again, how this conditional probability is working, and we are having this one third of the probability. And then the next step, going to bias theorem, fundamental concepts in probability and statistics, and then we are combining also these probabilities. We're actually also traveling back perhaps in time. So the B occurs and then R follows, or we can change again the time travel. The A occurs and B follows. And then here you see both this probability A and B, or here also this description. So probability, so the posterior probability, the probability of event A occurring given event B. And otherwise, so likelihood, the probability of event B occurring given event A. And all these, so what we also need to know, the general probability of event A and this general probability of event B. And all these possible combination of probabilities describes this bias theorem that are just saying if you, again, traveling from B to A or from A to B, then they are connected. So then this probability again of A in case B occurred equal, we are multiplying the reverse probability of B occurring in case probability B coming into C in case A occurring times the probability of A and dividing by the probability of B. And here we are also having this symmetry between A and B. So if you just imagine and you change all these B's with A's, then this formula would be the same. And then we can again see some examples in Python. So this is again classical medical tests for rare disease. We are imaging, so it affects 1 in 10,000 people. A test for this disease is 99% accurate. So meaning that just one, so occurs 1 in 990% of people with disease can get this disease. And if a person tests positive, how can we explain this? So someone is coming to this medical tests, getting these results, and we have to explain the meaning also of these results. What is actual probability that this person they have the disease? And then in this case, we're also following just using this bias theorem. And here, so this also Python code, we define the probabilities based on the problem. So then probability for the disease 1 to 10,000 per disease, so prior probability. And probability for no disease, for you don't have this disease, is just 1 minus the probability of disease. So probability no disease. And then we calculate in the likelihood. So the probability, so given disease, this is 0.0990%, and the probability positive given no disease 1 minus, again, this 99%. And then the next step, then calculating the marginal probability of testing positive. And here, this again explanation how considering formula we are calculating this here, and here the next is just the calculating, considering this equation, the probabilities here. And now this next step, we can apply the Bayes theorem to find the probability of disease, real disease, if the test is positive. So after this testing for positive, still how big the probability that this person has disease. And then again, the calculation, probability disease given positive, then probability given disease times probability of this disease, in like this explanation A and B, and dividing by this P probability that is positive. And after that, we just again printing this disease. Let's copy this code and run in new cell. And here it's really so very quickly, just multiplication and divisions, the probability 0.0098. So this is the probability. Still, if you have this test positive, then probability, so you have disease given these tests. So that is still better to have more, perhaps again, if you would like to increase this probability, you need to go to and test perhaps different, go through different tests. So the output, this code will be approximately, also here, Gemini explained this, what we get also through this calculation. And this might seem surprising, but it means that even with the positive test results, there is less than 1% chance that the person actually has the disease. This is because the disease is so rare that the number of false positive from the healthy population is much larger than the number of true positive from the interacted population. So again, these are very short steps. So the main that we also were looking at, the probability, so condition that something happening after something happened. So again, then we are how we using this writing P A and this /B, and then we can also Bayes theorem. So the next, that giving us this kind of symmetry that we can also calculate, then we exchange this occurrence of something, so A and B, and we are so possible. So go to this reverse time, I say reverse time, to have the also possibility that not the A first and then B, but also the B first and then the A. So if we consider these directions. So then we can check. So Anna, do you have something to perhaps to add?
No, I'm not so familiar as you are with this topic. But I just wondering, I started searching what is practical use of Bayes theorem in machine learning, because the main goal of this course, it's at first it was machine learning math club, now it's AI math club. So is this useful knowledge? Yes, I wanted to write the same prompt asking Gemini.
The I spell first. The purpose, the purpose of Bayes theorem I was writing in machine learning. So we are asking in corrected. So now it's correct. The purpose of Bayes theorem in machine learning, we can ask and check. So we can start deep research, or also start Canvas with building demonstration app on Bayes theorem. That could be also very interesting. We'll see. So very interesting to update our beliefs in the face of new evidence. So the comments on new evidence. This fundamental concept of learning from data, so again, is central for machine learning. And the purpose of Bayes theorem in machine learning is a multifaceted, ranging from building scientific classification models to providing a framework for understanding and quantifying uncertainty. So I also see in machine learning, or especially again coming to these large language models, we are working with random calculations. So also the next part of sentence, the next word, it always calculated like what could be the next, the probabilities. We are setting our just choose random. So so again, speaking of random numbers last time, and here also calculating next word, it's just putting probability for possible next word, and then we have to choose which one randomly here, but also probabilities of we can after that combine. And I think now there are more and more so really deeper algorithms that are running, that you are calculating the word after the next word. So if you combine, then you can implement here already this Bayes theorem in case this word is calculated or probably chosen, what is the probability again for the next word. So we just not see in one step, but we can see in two steps or in many steps a little bit further, calculating these different occurrence. And here, let's check what else we have. Foundation of probabilistic classifier. Also, the most direct application of Bayes is in creating classification algorithms. And so the goal of classifier is to predict a class, and all these classification algorithms, they are so calculated again the probability of a class given the features. They also we see supervised, unsupervised learning, and then using classification, we are using this supervised learning that already we have these classes calculated or labeled, and now we have something unknown, and then we have to classify and put in this so right class, so spam or not spam, already on learned. So through the learning on we are learning through the labeled data. And here naive-based classifier, so very popular. If you go into classification parts, then you can use this naive Bayes classifier already as a library, just choose which one classifier you can use, and you can use this part of classifier. And the second, so example bias, inference in model parameters. So here, possibilities of quantifying uncertainty and regularizations. And okay, here's a SNOC bias optimization for hyperparameter tuning. Very interesting. And so summary. I think I can also make this in a separate a link. And Anna, you can connect this also linked with this very interesting to also connected sources that we have here to the course. I'll give you the link, and then so everyone interested can also check all these steps that we were going through here.
I can add this link in description on the video.
Mm-hmm. Yeah, yes, you can add this link.
Yes, I will asking you to share on email.
Here also interesting this summary, directly building classification models that are so probabilistic in nature, providing a framework for reasoning under uncertainty, which allows for more robust and informative models, and enabling efficient optimization techniques for things like, again, hyperparameter tuning. And I can also check sources. Then also I will connect the sources that was already there. We can also check. Can Canvas, and we're checking Canvas, and we'll see. And using Canvas, it's coding parallel to demo, interactive bias Theorem demo. And we see this HTML code. So like for the site. Then so it's just the header. Then we're having body, interactive bias, and then now we are having this preview. So now we can for this disease, so they can adjust the probability, just play with the probability. Then we can play with test sensitivity, again, probability of positive in case the person have disease, and also can change this probability. And then we can choose again for the probability of in case we have no disease, and then the probability for negative. So then I just made some changes, and then automatically we see the probability, so posterior probability that the person have disease in case this person get the positive test. So here with these three, so just we have three, I have to choose these three settings, and with these probabilities. Just let me a little bit that we see the whole. So now again, some changes, we see both. Then we are, so the probability for disease is very, very slow. We've got there 1%. Then the probability for positive in case of disease, we can make this a little bit smaller. And then we see this is, we are having increase in that the probability that the person have the disease in case of positive test. But increasing this other, it's again getting bigger. probability in case there were no disease and test negative, and run in the opposite direction. So then again, probability, so that there were no disease and also the test is negative, then we get this opposite, just 3.1%. And here, so for this, I've got this bias theorem, and then we can, after that, publish this nice interactive bias theorem demo for the explanation, this probabilities bias theorem, how it's connected in case we see some results and what these results is, the meaning of these results. Probability comparison. Okay, I have to check this one additional field we have here. Then we can again check the code and then check what are this perhaps the meaning of this additional field. But again, straight using Canvas, we can already play with these settings and just straight calculating these probabilities with this bias theorem. Okay, then I'm back to.
So, okay,
Anna.
thanks to you and thanks to Gemini. Today we dive deeper into bias theorem. When I watch Khan Academy explanation, of course, I had association with binary tree, but just because I develop not mathematical. But biggest thanks for your explanation, because for future diving into machine learning, of course, we need we need this intuition. So it's I understand that bias theorem is one of the crucial topics. So, and I think it's time. And one more time, biggest thanks for your time, for your descriptive explanation. And I asked you to share with me these two links that I can add them under this, under in description under the video. Yeah, so I think yes, I sent email to you. And so one more time, biggest thanks for joining. And I think that brings us to the end of today's session. So thank you, Svetlana, Google developer expert, exactly in machine learning. So biggest thanks for your time and for such descriptive explanation. This session was recorded and will be available later on our YouTube channel. And one more question, and it's more asking. Please don't forget to submit feedback post-event form, because your feedback really important for us to improve future sessions. And once again, thank you for joining, and see you in our next session. So, and Svetlana, if you will have time, I, of course, invite you to take part in our next session next week. And I'll send a remind on email. And if you have time, so just give me to know, so I'll let you.
Yes, and we'll see anyway in 2 weeks in Berlin. We are.
Yes. Oh, it's so soon. Yes. Oh, I stopped recording, and